So welcome to evaluating indefinite integrals, the idea. So just a quick reminder, the indefinite integral of a function lowercase f of x dx was equal to a capital F of x plus constant c, where the derivative of capital F of x, so capital F prime of x, is equal to lowercase f of x. So for an example, let's go ahead and evaluate the indefinite integral of cosine of x dx. So essentially what we need to do, we're looking at a lowercase f of x equals cosine of x. If we're working with the format we've been, the same notation we've been using. And so we need to find some function capital F of x whose derivative is cosine of x. Right? So it's very useful to really have your derivative rules down and your derivative facts down if we're going to be able to do integration. So just like when you're trying to learn your division facts as a kid, it's hard to learn them if you don't know your multiplication facts. Same thing here. Knowing our derivative facts will be helpful. So from here, recall, if we think through our trig derivatives, that the derivative of sine of x was indeed cosine of x. Okay. So the derivative of sine x was indeed cosine of x, which that's precisely what we wanted. So what we can do is we can set capital F of x to be sine of x. Then it does precisely what we want. And so we have the integral, or the indefinite integral, of cosine of x dx should be sine of x, and then plus c, right? Since we we could have any constant added on at the end. So this is taking the indefinite integral of cosine of x using the fact that we know that the derivative of sine is cosine. And then just note that if we took the derivative of sine of x plus c, these should all be antiderivatives of cosine. So when we take the derivative, we should indeed get cosine of x. So this does check out. Next up, we want to find the integral, or indefinite integral, of 6x squared minus 2x minus 4 dx. So I'm going to take this piece by piece. We need to find essentially an antiderivative for each of these little chunks. Remember that the derivative, we can take the derivative term by term. We can do similarly for the antiderivative. So we need some function with derivative six x squared. And then I'm going to color code. This one will need some function with derivative negative 2x. And then for the last piece, we'll need some function with derivative -4. So if we kind of ignore the constant or the coefficients, then we can focus on derivatives that wind up with an x squared. So let's figure out what derivative has an x squared. Right? And so if we think about it, power rule, the power drops when we take a derivative. So if we want to wind up with x squared, it probably came from x cubed. So the derivative of switch colors. The derivative of x cubed was 3x squared. So if we want to wind up with 6x squared, we have 6x squared is equal to 2 times 3x squared. So presumably we could take the derivative of 2x cubed, and we would wind up with 6x squared. Right? And so 2x cubed is going to be our first key piece. And then we go back and we have -2x. So again, we want what derivative has an x. So again, power rule, when we take the derivative, the power drops by 1. And so to get x to the first power, we came from x squared. So we have the derivative of x squared is 2x. And then -2x is just -1 times 2x. Right? So we could use the derivative of -x squared should be -2x. And so the piece that we're interested in here is -x squared. That will give us our -2x. And then if we look at aiming for -4, what derivative is constant? Right? And so if you remember our derivative rules, we have that the derivative of x was just 1. And we're aiming for -4. Well, -4 is just -4 times 1. And so we could now look instead at the derivative of -4x should be -4. And so the piece of interest to us here is that -4x will get us the -4 we are looking for. So I'm going to just give myself a little more room. So putting this all together, if we take the derivative of 2x cubed minus x squared minus 4. Yeah. Derivative of 2x cubed minus x squared minus 4x. Here we go. Those are the 3 pieces I underlined. Right, so this was our purple component, our blue component, and our green component. If we take the derivative of this function, we wind up getting 6x squared minus 2x minus 4, which was our target, what we were trying to integrate. And so we have that this is a possible antiderivative. So this is an antiderivative. And we get, therefore, that the indefinite integral of 6x squared minus 2x minus 4 times dx is equal to 2x cubed minus x squared minus 4x plus c. So note again that indefinite integral is an gives us the antiderivatives. So by definition, if we take the derivative, it should spit back out the original function. So note to check the indefinite integral, just take the derivative of your answer. So we did this in both of these examples. So we checked in this step here, we were checking. Right? So to check, I'm just going to put stars. And then in our cosine, we did our check here. Right? So we had our 2 checks. And so one way you could write this is that if we take the derivative of our indefinite integral of lowercase f of x dx, we should wind up simply with lowercase f of x. So this is just kind of finding the indefinite integrals in a maybe not completely efficient way, but it gave us the indefinite integral. In the next video, we will sort of get some tricks and some common indefinite integrals.